Day 20, Trench Map. With the scanners fully deployed, you turn their attention to mapping the floor of the ocean trench. When you get back the image from the scanners, it seems to just be random noise. Perhaps you can combine an image enhancement algorithm and the input image, or puzzle input, to clean it up a bit. The first section, this right here, is the image enhancement algorithm. It is normally given on a single line. Okay, but has been wrapped to multiple lines in this example for legibility. The second section is the input image, a two-dimensional grid of light pixels and dark pixels, where the pound is light and the point is dark. The image enhancement algorithm describes how to enhance an image by simultaneously converting all pixels in the input image into an output image. Each pixel of the output image is determined by looking at a 3x3 square of pixels centered on the corresponding input image pixel. So to determine the value of a pixel at 510 in the output image, 9 pixels from the input image need to be considered. 49, 410, 411, 59, 510, 511, 69, 610, and 611. These 9 input pixels are combined into a single binary number that is used as an index in the image enhancement algorithm string. For example, to determine the output pixel that corresponds to the very middle pixel of the input image, the 9 pixels marked by the brackets with dots would need to be considered. So these are spread out, the ones up here, just spaced out by an additional one to fit the brackets in. Starting from the top left and reading across each row, these pixels are ... then pound ... then pound . Combining these forms ... pound ... pound . By turning dark pixels into 0 and light pixels into 1, binary number 00010010 can be formed, which is 34 in decimal. The image enhancement algorithm string is exactly 512 characters long, enough to match every possible 9-bit binary number. The first few characters of the string, numbered starting from 0, are as follows. Let's see. This is the top. Okay, yep. Okay. So then in this, in the middle of this, let's see, in the middle of this first group of characters, the character at index 34 can be found. Light, or pound. So the output pixel in the center of the output image should be pound, a light pixel. This process can then be repeated to calculate every pixel of the output image. Through advances in imaging technology, the images being operated on here are infinite in size. Every pixel of the infinite output image needs to be calculated exactly based on the relevant pixels of the input image. The small input image you have is only a small region of the actual infinite input image. The rest of the input image consists of dark pixels. For the purpose of the example, to save on space, only a portion of the infinite size input and output images will be shown. The starting input image therefore looks something like this, with more dark pixels extending forever in every direction not shown here. Cool. By applying the image enhancement algorithm to every pixel simultaneously, the following output image can be obtained. Okay. Through further advances in imaging technology, the above output image can also be used as an input image. This allows it to be enhanced a second time. Truly incredible. Now the small details are really starting to come through. After enhancing the original input image twice, 35 pixels are lit. Let's see. Okay, start with the original input image and apply the image enhancement algorithm twice. Being careful to account for the infinite size of the images. How many pixels are lit in the resulting image? So this is just this is just a, what do you call it? A offspring or whatever of Conway's Game of Life. So what I will do is, I've got my puzzle inputs right here. So this is all, I guess, technically one line. So I'll need to make sure it's read in as a single line. And then we've got our gigantic input image. Cool. All right. So there are lines. I'm going to print lines just to see what we have. Looks like it read it in the. So what we do is actually print length of lines 0, and this will clear that. Yeah, cool. 512. Okay, so it actually reads it in as one line. That's good. Okay, so we'll just do code equals lines 0, and then we will do image equals lines 2 and on, because the middle line is just a regular old space here. So, and then all these are split up, which is fine because I want it to be like that. So it expands out. So I need to, let's see. So when I start, every single dot that's inside and outside by 1 of the image needs to be checked. And then it will increase by an additional 1. Okay, we'll do get binary. And then so we're passing in the we're passing in the position we're starting at, or X and Y or whatever. And then we are looking at, or we also need to pass in the image as well. Okay, so then for I in 1, 0, 1, because we're considering every single one. Let's see. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay. So then I'm essentially copying this. Copying. Okay. Then I need to make the x, so xy equals position, and then if x plus I is less than the length of, or no, less than zero, yeah, or I plus j is less than 0. This needs to be j because I copied it. Cool. Hi, Diaper. How's it going? How are you doing? Love the name. It's great. Have you done Advent of Code before? Alright, let's see. So if x plus I is less than 0 or y plus j is less than 0, then I need to keep track of the binary string equals. Do I need to do binary string? Because I'll do int and then code 2. Yes, okay. It's binary string. Awesome. So then binary string will let's equal just a plain old dot. Okay. Because it's dark and it's outside of that. Yes. Okay. And then, oh, it's in order. So I need to make sure that I check top left, top middle, top right first. So I need to, it needs to be X. So yeah, this, okay, looks, I think everything looks good for what I have right now. So, if I could just continue, but let's do this. If x plus I is greater than or equal to the length of image or y plus j is greater than or equal to the length of image x plus I, or I don't think it just matters, does it? I'll change it back if it gives me problems. Then also the binary string will be an additional dot. Okay, so then binary string, let's see, it is what it, oh, I don't want to do dots. We'll just do zeros, I think. Yes, zeros. And then the binary string plus equals image. Oh, this is where I check. If image at x plus I, y plus j equals pound, then binary string plus equals, this is where it's equals 1 or add on 1. Otherwise, binary string plus equals 0. Yeah, that's fine. Okay, so then after I can return int binary bin string base 2, and then let's see. I think that's all I need in this one for get binary. Okay, so what I need to do now is probably have the next because it also needs to be I need to like add a buffer around them. So let's see. If this goes in, it's going to check everything around it. It's always going to be at least one. If there's 3, let's see. 1, 2, or is it 0? 0, 1, 2, 3. Okay, I don't have to worry about that too much. Okay, so what I'm going to do is I'm going to add a buffer. Awesome. Yeah, I've pretty much exclusively programmed in Python for like what 10 years, just on and off. I've had it a little bit difficult just because of like anxiety or whatever, learning another programming language, but yeah, we'll see what happens in the near future. Yeah, I forgot that I had a dog in this room. Okay, so what I need to do is I need to add a buffer. So image will equal so it needs to be dot times length of image 0, I think, and then I also want to, let's see, plus image, and then I just do that again. And then we'll see how it looks. Oh, actually, I can do this. Okay. When I go through the loop, so I'll move this a little bit. Image equals buffer image. Okay, so what this is going to do, so another helper function, it's going to be buffer. I'm going to take the image. Oh, because then I need to also add it on the outside. Okay, so the buff, yeah. And if I do anything and you're wanting to know what or why it is I'm doing it, or want me to explain anything in Python, I guess, then go ahead and ask, and I'll do my best to explain it. Okay, so the buffer is going to be I need a top buffer, well, top and bottom buffer, and then I need to go through each line and add a dot at it. Okay. All right. So. Oh, thank you so much. Really appreciate it. Thanks for the follow, Diaper. Okay, so buff Top and bottom buff. Top, bot, buff. Woohoo. Equals. Oh, and then I can add. Okay, so this is good. Okay. Equals. And then this is where I do this dot thingy and then times the length of. Because what I'm doing is expanding a string. I don't know if you know. String multiplications, it like prints that many times or whatever. So this is the length of the image, 0. And so then image will equal top bot buff plus image plus top bot buff. Okay, but then what I need to do is go through the image for row and range length of image. What I'm going to do is image at the row is going to equal a dot because it needs a buffer plus image row plus another dot afterwards. And then what I do is I just return the image because I am just buffing. I'm just adding a dot at the end. So that is good. So binary string is 0. I do not. No hablo español. Let's see. So then I don't have to worry about the image down here. So code equals line 0, image equals lines 2. This code, let's see. Okay, so loop. Okay, so this is where I do the for, whatever in range. In this case, it's going to be 2 because it's asking us to do it. To start with original input and apply the image enhancement algorithm twice. So 1, 2. So this is what that for loop's going to do. And what it is, so I'm going to buffer the image first, and then, so I have the ability to get the binary representation, or get the binary number of each individual dot. But now what I need to do is go through each position within it and add it to probably add it to another image. So I'm going to do this in another function. Let's see. Enhance image. So we need the image, we need the code. Do we need anything else? I don't think so. So what we're going to do here is image will now equal this enhanced image. And then we're passing the image and code. So we only have to worry about, in our main function, we don't have to do everything. And here we'll have the next image is going to equal, it's going to be a list. And then I go through for X, let's see, for row, x. Well, yeah. So for x in range, length of image. For y in range, length of image x. We're going to next image. Because for each row, I want to be row equals a string. The next image. No, in this case, it's going to be row. So row plus equals code at the get binary of the position and image. So get binary position is going to be x and y, and then we are passing in the image. Because this returns that integer, and we're getting that position in the code. Okay. And then after all that's done, next image, we will append row. Okay. And then we just return the next image. So, and then we go through and we check how many pixels are lit. Yeah, they're all lit. Okay, so get lit of the image. So we're going to do another helper function. Def get lit. We got the image. Count equals 0 for row in image, for pixel in row, if pixel equals pound, then it is considered lit, and count plus equal. I could do count. So right here, all I do is just count plus equals row dot count, and then the pound, because it's just a string. Let's see. Strings have count, right? Return count. Let's run this on the sample real quick. Okay. This one might not be the same. Let's see. Okay, yeah. So I'm gonna have to, for sample, I need to put all these on the same line. Okay. So let's try that real quick. Sample input. 35, 35. Okay, so then let's try it on our input, and 5406. Oops. 5406. Answer's too high. Okay, so let's see. Let's see, image equals enhance image. Image encode for X in range. So I'm thinking it's probably, okay, so it starts at, wait, does it start at 0? So it starts at 0, 10, 20, 30, 40. Let's see. Binary number could be foreign, which is 34. Okay, let's see. Top, middle, bottom. Supposed to be 1, 2, 4, 8, 16, 32, 64, 128, and 256. Okay, so if we return the int, I think that's right. 406, it was too high. Count plus equals row dot count pound. 1, 2. Turning the next image. What do you think? What do you think is going on here? Top, bottom buff. So we add the top, bottom buffer. So it's dots because they're all dark. They add dark to everything. Enhance image, image code, next images. New list. And we've got a row. And then we go through image X. Row plus equals code. Get binary. Let's see. This would be 0, 1, 2. So let's look at our sample input and print out our image. We'll pretty print it. Need to print it after, not after the buffer, but after the enhancement. Looks good. Yeah. Let's look at the input. So there's 100. By 100. And the code is 512. Right? Let's check real quick. Yep. adds it is when I buffer it, add the row, and then that allows it to fill up. And then I need to buffer it again, because everything else makes the binary makes it lit. So if because it's an infinite plane, if we look at the sample input, all dark is going to make it dark. And if there's one light, it's still going to be dark. But on the input, everything, if it's completely dark, it's... And also if we look at the last one, if everything's lit around it, then it's dark. So it needs to flip each time or something. So at first these are all going to be dark, but then the next one, everything that's more than one away is going to be lit. A little bit more difficult. I don't know if it's just me or like, well, not just me, but so let's see, how do we determine what I buffer it with? So at first I'm going to buffer it with dots. Then all these are going to be lit, lit, lit. Is that one going to be lit as well? Yeah, all of these are then going to be lit. Everything on the outside. Okay, so let's check. Okay, buffer, image, and then let's do style. T per time, pass in T, so the buffer is the buffer also needs to be checked. What am I coding? Okay, so I don't know, like there are special cases in which the first what do you call it, bit of the code and the last bit of the code are well, mainly the first one. The first bit is bright, like or pound. And so when I go through the input or my input, if every single pixel within that 3x3 grid is dark or a dot, then it becomes a lit pixel. And because the space or the image we're looking at is theoretically infinite, all spaces that are on the outside will then become light or become lit. But then, because the end of my code, if all of them are lit, then they all become dark. And so it swaps every iteration. So I'm trying to figure out how I go about adding the buffer to check. So does that make sense to what I'm doing? So if time, so I'm not sure. So if they flip afterwards, so I buffer with so I don't think I'm always going to buffer with whatever's on the outside. Let's see. If I look here, I think it's fine because this should always be one bigger than what it is before. So I should buffer it with the okay, so if t module 2, that means if it's not divisible by 2, then I'll then character will be else character is the dot. So top buff, it actually, instead of having it set, it needs to be character. It needs to be character as well. So let's see if I run that. I'm also going to pass code in here so that it changes time and code. Buffer code. If code 0 equals pound, then I have to do this, I think. And code -1 equals dot. Then I do this. Otherwise, character equals dot. So then if I run this on my sample, I get 35. Yeah. String index out of range. For y in range, okay, so row is nothing currently. Row plus equals code. Get binary. Row. Okay, so string index out of range. So that means get binary is returning something that's too high. let's see. Binary string 2. We will print binary string just to look at it real quick. One, 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 which is 512, or no, 511. Apparently 511 is too large. Let's see, for binary string, we turned it integer. Oh, wait. No, we're doing input. That's fine. So, oh, okay. I think I may have deleted something. Yes, I did. So let me get my input again. Oh, wait. I think I accidentally deleted the first character. Yep. Okay. So, there we go. That'll fix it. And let's not print that out anymore. Okay. And let's see, print image. I don't want to print it every time. Columbia. Nice. What? Get the same number. Shoot. Oh boy. Okay. That's interesting, actually. T in range 2, so it does 0 and 1. So the first one we're going to buffer with dots. I can do this. I mean, I did the previous day, which seems a lot harder than this. Character times length of image 0, and then do that. Character plus image row plus character. I think what's happening is within my code, let's see, or my image, whatever, where I see, let's let's see, so there's like 3 right here, so this one would be all bright next. Let's see. $54.06. Let's check. So my buffer, I don't think it's working, or it's gonna work because let's see, if I add that on, if they're all lit, let's see, let me zoom in a little bit. So if I look at this smaller one, I'm gonna have to add a buffer, let's say like in this area. These are all included, even these 2 dots right here. So this dot, the initial buffer is going to be a dot, which is good. And so then it's going to check all these dots. And then this one would turn into a pound. Sorry. This one would turn into a pound, and then this one would also be pound, pound, pound. This one is probably pound as well because there's only one light. But this one would not be pound, pound, and then pound. So the next buffer I do this one has one that's not. So I need to do like the whatchamacallit. So instead, I need to go through each side. Okay. So this buffer, I have to also get the binary for it, which is really weird. So this code character thingy, I don't think I have to worry about that. Okay, so this the character I'm checking, that's on the outside of the buffer. Oof. Top and bottom buffer. So this isn't going to be. So if it's not within the current grid I have, then the buffer is what the current time is. Okay. So let's see if time module 2 equals 1, the character equals pound. Okay, that's fine. I think this is fine right here. Obviously I'm changing stuff right here. This is really freaking bad. I don't know why I did that. Let's run my code again and see what it does. If that was my problem, I'm stupid. Oh my goodness. If this works... Okay. Okay, it's not the right... It's not right. I think we're okay. I was still too high. Okay. Wait, I didn't mean... I should have checked my previous answer because this is higher than my previous answer. My previous answer was too high, wasn't it? Silly me. Okay. Okay. So, there. Okay. So let's see. Time equals 1. Character equals pound. Okay, that's fine. Top and bottom buffer will then not be a thing. Image equals top bot. Okay, so we need to get that. So the buffer then needs to be, let's see. I need to do, what, like a copy of, let's see. So I have my image, and then I need to check all of them that are around it. But then I need to make sure I add them on afterwards, so I don't mess with the image. So I can do the top row, bottom row, and then I'll do the left and then do the right. Okay, so let's do this. So top and bottom are essentially the same thing. And then left and right are essentially the same thing. So with top and bottom, so for, well, X will be -1. And then for Y in range, -1 to the length of image +1. But then, actually, no, I'll just do two separate for loops. So yeah, this one's going to be the top. Pass that for a second, and then I'll have the bottom. Yes, and I'll do the same thing for the left and right. So then X equals length of image. And then so but then this is the same thing. And left and right are going to be a little bit more interesting. Sorry. Y will equal -1. Let's see. This is just the complete opposite. So for X in range, Um, I should do the rows, then add those on. Or actually, I shouldn't add them on yet. But then I do, what? You can come inside. Shadow. You can be here. Hi, baby. Hi. Boop. You cutie. You cutie. Okay, so I think here I'll just do y equals this is for the row I want, so y equals -1, and then I'm going through the different rows, so I need to check because I'm already going to check -1 with this, or with the one up here, and so I don't need to start at -1x. I just need to start at 0, but then just go to the length of the image. And this one needs to be length of image 0. And then also this one. This one's length of image because of the different axis. Just in case it doesn't grow equally. Let's see, and then I don't think I need to add one to it. Length of image, because we're going this way, so it'll be 0. Yeah, I think length of image is good. And then we'll do that in a minute. And then so this one's gonna be the right where y equals length of image 0, and 4x in range, yada yada yada. Length of image. It's my brother's dog. It's like a border collie Labrador mix. He's a cutie. He's a couple years old. Okay. So then as I go through, top will equal string. Oh, it needs to be above this. So this will be so top, and then bottom. Oh yeah, just give it that. Okay. And then left is going to be a list. Could actually make it a string as well. And then right. Okay. So then I just do the same thing. Forget binary. And I think here I should also pass in the character. No, because this is just for the buffer. No, I do. Well, do I need to? leave that in there just for now. I am from the US. So, let's see. I want to check specific areas. So X, Y. Position and then the image. I can do get binary, that's fine. And then I can improve the character here. If character equals pound, then value equals 1. Value equals 0. So in this case, I can just change this to value, and then wait. If it's outside of it. Okay, so this is if it's less than the, or you know, if it's not within the image. Then I return this. So this needs to be value. Or if it's greater than the length of the image, then also needs to be value. And then, so if it's within the image, if it equals that, then it's at that. Otherwise, okay. So I think we're good. Position, image, character. So then I need to get binary. Where do I run that? So I need to enhance the image. Row plus equals. Let's do this. And buffer. So let's see. Get binary X, Y, and then the image, and then our character. And so I just copied this for this one, just naming bottom. Okay, and then for these ones, it's gonna be a little bit different, right? Or actually, for X in range length image. No, I don't have to change it at all. I just have to have left and then right. So afterwards, image will equal top plus image plus bottom. And then for so there's index and then character or value or whatever, and enumerate left, then image. Oh, this is where image I equals image it should be, let me do this. So left index plus image index plus right index. So instead of doing that, I'll just do the range, the length of left. Left index, image index, right. Image, yeah, I think it's right there. It's the row, and then the right row. And then I return the image. Oh my goodness. Let's see a break. A not list to string. Okay, yes. Where are you? Line 57. And then I think this one's fine. This is a no, it's a string. String. 5435. What was my 5406? And that was the first one, I guess. But it doesn't matter because it's still too high. Ugh. This is frustrating. Buffering. Got a character. If code 0 equals pound and code -1. Let's see, getting binary. If character equals that, value equals 1. So we go through. So we initially go through the buffer. So if we're looking at the top, then x is -1 and y is -1 at first. So, but then we're going to do an additional. Let's see. So it's going to be -2. It's less than 0. And so it's going to be the value. Thank you. So yeah, so we it's going to be value, which in this case, the next buffer is so it starts with 0, right? Or let's see, what character do I pass in first? So it starts with 0. Are these switched around for some reason? Like if this is, should this be 0 and 1? Let's try it out. I'll have to wait 5 minutes before if I get it wrong. So I think that'll give me plenty of time to. Too high still. Okay, too high still. All right. So let me switch those back because I don't think that was causing a problem. So if the character, if the iteration is divisible by 2, well, not divisible by 2. If it's not divisible by 2, then our value is going to be a lit pixel. Value equals, so equals position, cool. Binary string equals nothing for I, -1, 0, 1. For J, -1, 0, 1. If x plus I is less than 0, y plus j is less than 0. So if it's less than let's see, if it is -1, then obviously checking its placement on the, because it's still a buffer. I know what I'm saying is like gibberish right now. But if x plus I, so if it's not within the grid, then it's going to be the, so we're just creating the buffer. the first time I go through, they're going to be, it should be 0. The second time I go through, it should be 1. If it's greater than or equal to the length of image, it's also that way. Let's see. X plus Y plus J. It should always be the same size. X plus I greater than or equal to the length of image. So in this case, let's see, y is -1, and then y is the length of that. Just so let's see, the sample input is 5292. Okay. It's 5. And so then I'm passing in 5 because I want to get, or set that value at that location. Top is -1, and then I go beyond the length because that'll be set. Wait. No, I think we're fine there. Let's see. So if we're looking at 5, is it just y? So if y equals 5, and then j is going to be negative, so that's going to be 4. Greater than or equal to. 4 is less than the length of the image. And so it'll check if it's lit, then the string is 1. Great. If it's not, then the string is 0. But then it's going to go to the next one. And it's going to be greater, and it's going to assume that it's now lit. Pixel buffer. I have unintentionally made this a little bit harder than it probably should be, but oh well. And if I don't figure this out in just a couple minutes, I'm gonna redo my adding my buffer thing. Yeah, here. Let's see. Because if I'm checking buffer at that position, I'm gonna do it. You go eat something. Hopefully it's yummy. Bring some back for me, right? Enjoy, enjoy. Thanks for stopping by. Thanks for following. So as I'm going through the buffer, creating the buffer, okay. Yeah, what I'm doing is kind of advancing when I shouldn't, is at least what I'm thinking of. And so I don't think this is going to work. So what I should do is bring these back to whatever value they were. 0, I think. So 0. Get rid of this character thing. Actually, let's see. Maybe in this one I can keep it. Get binary position, image, and character. So the character is going to equal, yeah, so I can keep this one in there. And so I can leave this in here. I think this is fine. I think get binary is fine. Buffer. I don't need to do anything crazy. What I'm going to do is in the beginning, I'm going to add those dark dots, or unlit pixels. And so what I do is so it equals buffer, and so each buffer will then add 2. Let me just comment this out, just in case. Okay, so this is going to be top and bottom equals character times the length of image. 0. And then left and right are going to be the same thing. Actually don't need this to be. So image now equals buffer plus the image plus the buffer, And then for in range length of image, image I equals buff I plus image I plus buff I. I'm pretty sure this is what I had before and didn't work. Then I just return the image. Or maybe instead what I'll do is add twice the buffer. So this actually needs to be 1 to the length of image plus 1. I thought it'd work, dang it. Sorry. Why do I not just do character? Silly me. Still keep getting random ones, so. Get binary, $52.18. We're gonna try it. Okay. That works. I accept it. You still can't quite make out the details in the image. Maybe you just didn't enhance it enough. If you enhance the starting input image in the above example a total of 50 times, start again with the original input image and apply the image 50 times. How many pixels are lit in the resulting image? So let's change this to sample. And then also just change this to 50. And that's going to print a bajillion times. Okay. Well, I mean, obviously that one works, but we're going to print out every single line in my input. Right. Oh, cool. That didn't take as long as I thought it was going to be. Hey! Oh, man. Okay, so What did we learn? I need to figure out a better way. Let's see. Actually, my buffer right now is just going to be the character. Yeah, it should be fine. So each time the enhancement runs, the buffer 2 times out will be the same as everything else. Buffer next to it, well, buffer, call it buffer, but it's not really. The buffer is just allowing those pixels that are nearby, because everything outside the buffer is what the buffer is at that moment. Cool. If that made any sense. Probably didn't. So we're gonna not print this out and see how long it takes. Algorithm takes 2.14 seconds. It's fine. There's probably a better way to do it. At the end, I do want to print the image just to see what it looks like. We're pre-printed, of course. So it's now huge. But I'm only growing the buffer by 1 each time, and so resulting the interesting thing is the very top is all dark. The very right is all dark. The very left is not all dark. The top and right are all dark. What's going on there? Adding it twice accidentally. So buffer, image, buffer. I wonder what would happen if I just took out this top buffer and the buffer on the right. $15, $5.27. Nope. Okay. That's really interesting. Nice. 15, 5, 27. That is my answer, and I'm right. Yes. Cool. So, stay 20.